In this video, we're going to talk about a binomial distribution. And the first thing we're going to discuss is properties of a binomial distribution. So the four properties that outline if a binomial distribution occurs, the first one is the experiment consists of n repeated trials. The second one is that each trial results in two possible outcomes. That's where this term binomial comes from. And if the probability of success is pi, then this implies the probability of failure is 1 minus pi. And the fourth and final thing is the trials are independent. If those four things happen, then we have a binomial distribution. I'd like to make a note here. This pi is not 3.14. This is used as a variable to represent the probability of success here. Okay? And now let's ask a question where a binomial distribution occurs and see what kind of questions we can answer related to this type of object or situation. Okay, so here's our question. Example, let's find the probability of rolling exactly 1/6 on a 6-sided die in 4 rolls. And let's see how we could possibly answer that. Right? So if we had 4 dice rolls, any selection of this first dice roll, any selection of the second, third, and fourth could occur. So this is 6 raised to the 4th possible outcomes. We want to know the probability that the outcome we select has exactly 1/6 showing up. In other words, if we counted all of the outcomes where exactly 1/6 showed up, and we divided by the total number of possible outcomes, then that would give us our probability. So how could we possibly come up with that? Well, let's first consider the probability that we roll a single 6 on the first die, and we do not roll a 6 in the other 3. So our probability of success here, success means roll a 6. So our probability of success is equal to 1 out of 6. Our probability of failure, so not rolling a 6, is 5 out of 6. And the probability of rolling a 6 on the first roll and not a 6 afterwards. Well, what is that probability? That probability is 1/6 raised to the first power times 5/6 raised to the third power. Because the probability on the first roll is 1/6, and then the probabilities on the last 3 rolls are 5/6 that we do not roll a 6. And there are 3 of those. So to find that probability, we just multiply. 1/6 times 5/6 times 5/6 times 5/6. And so we know the probability of rolling exactly 1/6 when that 1/6 is on the first roll. But that 1/6 could have also been on the second roll, or could have been on the third roll, or could have been on the fourth roll. And in fact, the probabilities of each of those individually would have been this probability right here as well. So what we should do is multiply the probability of each one of those events, where we roll exactly 1/6. Got to multiply that by how many different ways that could have been done. In this case, it's pretty easy to see that could have been done 4 different ways. We could have had the 6 here, or the 6 here, or here, or here. But how do we actually calculate that using a formula that we already know? Well, if we recall from our accounting rules section, this is essentially how many out of 4 options, how many ways can we choose one of those 4? So out of these 4 options, how many ways can we choose the 6 showing up in one spot? Right? i.e., we use the choose function. So let's talk about that real quick. So we just wrote the probability of 1/6 showing up in the first roll, but the 6 can show up in any one of 4 spots. So how many ways can this happen? And again, according to our counting rules section, this was exactly 4 choose 1. So what is that? Well, that was 4 factorial over 1 factorial times 4 minus 1 factorial, which is 4 factorial over 1 factorial times 3 factorial. 4 factorial divided by 3 factorial just leaves us with 4. 1 factorial is 1, so this is 4, which matches up exactly what we said earlier, right? When we just counted and we said that that would be 4 times. So, the actual probability of rolling exactly 1/6 on a 6-sided die in 4 rolls is 4 factorial over 1 factorial times 4 minus 1 factorial. This is the number of occurrences times the probability of one of those occurrences, which again was 1/6 to the first times 5/6 to the third power, which is 4 times 1/6 times 5 to the third over 6 to the third, or in other words, 4 times 5 cubed over 6 to the fourth. And that would be our probability in decimal form. Now let's go ahead and write out the formula here that we just came up with. So, for binomial distributions, the probability that the large variable x here is equal to this lowercase x, n comma pi, where n is our number of rolls or number of trials, and pi is the probability of success. This is n factorial over x factorial times n minus x factorial times pi raised to the x times 1 minus pi raised to the n minus x. And that is our formula. Again, what is n? N is the number of observations, or number of trials. Whichever word you prefer there. pi is the probability of success, or a probability of an event of interest occurring. Okay, 1 minus pi is the probability of failure. And x equals the number of events of interest that we want. And always x is equal to 0, 1, 2, all the way up until n. X can only be one of those values. All right. And again, this is our formula for calculating something like this. And we've already seen an example where we actually came up with this formula. And it turns out this is our formula every time for something like this. We'll go ahead and end this video here.